We're continuing with chapter 19, which is about confidence intervals for proportions. Yesterday in the video, we created a confidence interval for the actual percentage of C fans that were infected with some kind of disease. We found out that our interval was from 42.1% to 61.7%, and we calculated that by adding and subtracting 2 times our standard error. So we claimed that we had a certain confidence, 95%, that the true proportion of all infected C fans was in between our confidence interval. So we again calculated that by taking our sample proportion, which is p hat, and adding and subtracting 2 times our standard error. The extent of the interval on either side of our sample proportion is called the margin of error, which will be abbreviated as ME. In general, a confidence interval looks as follows. It's your estimate, so in our case our sample proportion, plus and minus your margin of error, where your margin of error is how many standard deviations you are from the mean times the standard error. And again, the margin of error is how far you are above and below what your sample proportion was. Continuing talking about margin of error, we're going to look now at certainty versus precision. Our margin of error for 95% confidence is 2 standard errors. We take our standard error and multiply it by 2. That gives us our margin of error. If we wanted to be more confident, we have to make our margin of error bigger. We could be 99.7% confident if we make our margin of error 3 times the standard error. So now instead of multiplying by 2, we're multiplying by 3. That makes our interval wider in that case. The more confident we are, the larger our margin of error is going to have to be, and therefore the wider our interval will be. We could be 100% confident, but the only way we can be 100% confident is if we say that some percentage of C fans are infected. So by saying that it's between 0 and 100%, then we can be 100% confident. But that doesn't help us. That's not very precise. We're very certain, but not very precise. We could be very precise and say that the number of infected C fans is from 51.8% to 52%. But we won't be very confident of that, so we won't have a whole lot of certainty here. The trick is to have a balance between both. We want to be as certain as possible, but we also want to be as precise as possible. So the most common confidence levels that will end up being used are 90, 95, and 99%. We'll also end up using 98% as well. But you can end up using any level you want. I do warn you to be wary of a funky confidence level though, because if you see a confidence level of 67.3%, it's kind of an indication that the people who did the study want to have a specific value as their population proportion, and so they're making an interval to make sure that that value is actually contained. So you want to make sure that it isn't some crazy certainty. So just checking. Let's think about what a margin of error actually is and how that affects our interval. So if we think about a 95% confidence interval for the proportion of U.S. adults who may switch their vote. We did this in class and we said that it was from 15.5% to 20.5%. If we wanted to be 98% confident, would our confidence interval need to be wider or would it have to be more narrow? Because we're more confident, our margin of error is going to have to increase. By increasing our margin of error, our interval will have to be wider. Our margin of error was about 4%. If we wanted to reduce it to 3%, would our level of confidence be higher or lower? So if we are making our margin of error smaller, we'll be making our interval more narrow. So our interval will be becoming more precise, and the more precise we are, the less certain we will become. So our confidence level would end up being lower. If the Gallup organization had polled more people, so our sample size was larger, would the interval's margin of error have been larger or smaller? And the answer here is larger. A larger sample size is always better. So the larger the sample size, the more accurate your sample proportion will be. So the closer you'll get to your true proportion or the actual population proportion, and the smaller our margin of error will then be. Looking at an example, your local newspaper polls a sample of 330 voters, finding 144 who say they will vote yes on the upcoming school budget. Create a confidence interval for the actual sentiment of all voters. Use 2 standard deviations, and that should say standard errors, and concentrate on the interpretation. The first thing we need to do is find out what our sample proportion is. So our sample proportion, p hat, is 144, because that's how many said yes, out of our grand total, 330. So this gives us a value of 0.436. So then Q hat is 0.564, and I found that by doing 1 minus 0.436. Once we find this, we need to find our standard error. So our standard error is equal to the square root of P hat times Q hat all over N, which is 330. And this gives us a value of 0.027. Once we find our standard error, we can find our margin of error. So our margin of error is 2 times my standard error. This gives us a margin of error of 0.054. Once we have our margin of error, we can then find our confidence interval, and our confidence interval, which I'm abbreviating CI, will be our p hat plus or minus our margin of error. So it will be equal to 0.436 plus or minus 0.054. This gives us a confidence interval of 0.382 to 0.49. So 38.2% to 49%. So this ends up being our confidence interval. But note that we want to concentrate on the interpretation. So identifying what the confidence interval is only gets us so far. We really are focused on what does the confidence interval actually tell us. So in order to interpret it, we have to give 3 things. We have to give how confident we are, we have to give the interval, and we have to explain what it means in context. That in context piece is extremely important. So the way we would interpret this is by saying based on our sample, because remember this is only based on our sample. If we were to base this on a different sample, we would get a different confidence interval. So based on our sample, we are 95% confident that between 38.2% and 49% of all voters will vote yes on the upcoming school budget. So that's how we would interpret it. Again, it needs 3 things. So when you are solving these problems on a quiz or a test, your confidence interval is worth however many points, but the interpretation is worth 3. You need to have your confidence level, what the interval actually is, and then what it means in context. Those 3 things must be provided.